Hey guys, we're back for our next lesson. Today we're looking at problem set 102, which is dealing with absolute value inequalities. Now, before we get into the inequality part of it, the idea of absolute value, we have a definition of absolute value that is the absolute value of some number is defined to be a distance from zero on a number line. Okay, so distance from zero on number line. Okay, that's the definition you need to have in mind. Now, if we have an absolute value of x equal to 3, okay, this first example, absolute value of x equals 3. So that means we are exactly 3 units away from 0 on a number line. So I have a little number line here. If I start by putting 0 on that number line, I want to go exactly 3 units away. So I could go 1, 2, 3 to the right, and I could land on that point, or I could go 3 to the left. 1, 2, 3 to the left. And if I go to the left, I'm on -3. So, an absolute value of some number equal to 3, I have 2 possibilities. I have +3 or -3. So 2 solutions to that problem. And if you think about it, if you take the absolute value of 3, you get 3. If you take the absolute value of -3, you also get 3. So when an absolute value of some number x equals 0, then you are exactly that many units away from 0 on either side of 0. All right? Now, when we start talking about absolute value inequalities, we're going to look at an absolute value or a distance from 0 that is less than a certain number away from 0, or an absolute value that is greater than some distance from 0. So I have 3 examples here, one with less, and then two with less than, one with greater than. So this first one, absolute value of x is less than 2. One thing about these absolute value inequalities, you always want to have that absolute value of x solved for on the left side of the inequality. So always get the absolute value of x on the left. Now, we have an absolute value of x is less than 2. So if we think about what if this was an absolute value of x equal to 2, where would we be? Well, on our number line, here's 0. And if I go exactly 2 away from 0, where do I end up? Well, I end up at +2 or -2. So those are kind of my boundary points. Those are my reference numbers, if you want to say. Okay? Now, I want a distance from 0 that is less than 2. Now, I don't have the equal to part, so I cannot go exactly equal to 2 away from 0. So if you remember on our number lines, when we don't have that equal to, how do we show that on our number line? Sometimes we had closed circles, sometimes we had open circles. When there's no bar under it, that means we have open circles at +2 and -2. Okay, now remember, make sure your circles are obvious, whether they're meant to be open or meant to be closed. Make sure that's easy to tell on your number line. All right, now, distance from 0 is less than 2. Less than 2 away from 0. That means I cannot go past 2. I can have any distance from 0 out to 2, but not past 2. So distances from 0 to the right, less than 2, would be anything in this region. And then to the left is anything in here. So my distances from 0 that are less than 2 away from 0 is everything in between -2 and +2. So that is my graphed solution. All right? Sometimes we may have to write that solution. I think right now we just need to graph it though, so we'll not worry about writing the solution just yet. Absolute value of x less than or equal to 4. Well, we start off the same way. Suppose we go exactly 4 away from 0. What are my reference numbers? Well, if I go 4 to the right, that puts me at +4. 4 to the left is -4. So those are the 2 reference numbers I need on the graph. Now this time, less than or equal to. So open or closed circle. When you see that bar under it, that means you get a closed circle. At -4. Again, make these circles obvious. Obviously open or obviously closed. Okay, and again, less than or equal to 4. So Can I go past 4? Sorry about that. Can I go past 4? No, I have to stay inside, less than or equal to 4 away from 0. So I'm shading on the inside. All right? Next one. Absolute value of some number is greater than or equal to 5. Well, here's 0. Let's start with our reference numbers. Exactly 5 away from 0 puts me at -5 or +5. Open or closed circles. It has the bar under it, equal to, so closed circles at -5 and a closed circle at +5. This time I want distances from 0 that are greater than 5 away from 0. So I have to go more than 5 units away from 0. So I can't stop anywhere in between here. I got to jump out past 5. So I want to shade on the outside. And I'm going to continue on out that way. If I jump to the left past 5, -5, I'm shading on the outside here. So there's my graphed solution. Things to remember. If your absolute value of x is less than or equal to, you're going to shade inside. If your absolute value of x is greater than or equal to, you shade out. Shade out. Okay? Less than in, greater than out. All right? These last two problems, they're a little bit different because we don't have the absolute value of x by itself on the left side. So we're going to need to use our little steps in solving equations to get that absolute value of x by itself first. So on absolute value of x plus 4 is less than 10. I'm trying to get this absolute value of x by itself. So my first step is I need to get rid of the plus 4. So to do that, I'm simply going to subtract 4 from both sides. Now remember, on your steps for solving inequalities, this inequality symbol will not change unless you multiply or divide by a negative. On this problem, I'm subtracting 4 from both sides. I can add and subtract all day long. It does not change that inequality. So that plus 4 is gone. I'm left with absolute value of x is still less than 10 minus 4 is 6. So I have the absolute value of x is less than 6. So it's going to work just like the problems above. Here's 0. I want reference numbers, so I want to know 6 units away from 0. Well, that's +6 and -6. Then my next question should be open or closed circles. Since it's strictly less than, that's open circles. -6, +6. And then distances from 0, that absolute value of x is less than 6. So can I go past 6? Nope. I got to stay inside. So I got to stay within those reference numbers. So I shade on the inside. Simple as that. All right, last one. I'm going to start by isolating the absolute value of x. So my first step is I need to get rid of that -3. So I'm going to add 3 to both sides. That leaves a negative. Absolute value of x is greater than -2. Now, I'm not allowed to leave this negative on the outside of the absolute value. So how do I get rid of it? Well, it's just like having a negative x. To get rid of that negative sign, I'm going to divide both sides by -1. Now, I just mentioned this. What happens in an inequality when you divide by a negative? Well, anytime you multiply or divide by a negative, that inequality sign right there has to change direction. So we're going to flip it over to less than. -2 divided by -1 is +2. So the absolute value of x is less than 2. So again, distance from 0, less than 2. Seem to have a lot of less thans on this page. Less than 2. So my reference numbers are +2, -2. What kind of circles? Open or closed? Well, it's not less than or equal to, so that's got to be open. And distances from 0, less than 2. So I cannot go past 2. It's less than, so I shade on the inside. All right? So remember, less than, shade in, greater than, shade out. as long as that absolute value of x is by itself on the left side. Now, one other thing I need to mention real quick. Put a little box down here so we can see it. Is it possible to have an absolute value of x less than or greater than, it doesn't matter, a negative number? So think about it. Can you have a distance from 0 that is less than negative 4 feet away or 4 units away? That's not going to happen. So anytime you see this, a distance from 0 less than a negative or greater than a negative, there is no solution to that. Okay? So, absolute value, remember, is a distance from 0 on the number line. We're going to shade inside, shade outside. Remember your open and closed circles. Make those obvious. Okay? Again, this is problem set 102, absolute value inequalities. Good luck. Hopefully we're successful with this. If you have questions, be sure to see me, watch the video again, and hopefully we can get this taken care of without much trouble. That's all.